force or elastic force okay, so what is this force? So this is force exerted by spring. This is force exerted by spring. Okay, so let us discuss this little more detail. Suppose I have a spring, I attach a mass here, and I start pulling this object. So if I pull this object with suppose 10 Newton, the spring will give a force equal to 10 Newton if this object is not moving. If I apply a force F equal to 10 Newton, the spring will develop a force in opposite direction. So this is the force which will be developed in the spring. So whatever external force we apply in this direction, the same amount of force spring develops in opposite direction. If the spring is expanded, suppose from natural length position, spring is expanded, then the force will be acting in opposite direction. And the more we expand, if we stretch a spring, suppose we have a spring, if we stretch this spring, if we stretch in spring, if we write the corresponding spring force, so we can have, suppose we stretch the spring by 1 centimeter and then we have 2 Newton force. If we stretch the spring by double amount, suppose we stretch it by 2 centimeter, then the force will become double of the initial value. It will become 4 Newton. If we stretch it 3 centimeter, it will become 6 Newton. So this is the property of a spring. It may vary slightly from this result, but this is most common result which we see with the spring. So if you stretch a spring by some amount, if some force is developed, then if you stretch the spring by double amount, the force developed will be double in the value. So this is just an example. So if you have a spring stretched, then the force is proportional to the stretch. So we can write F in the spring is proportional to X and minus sign. Why minus sign? I am saying X is the extension or compression. Extension or compression of the spring, or change of position with respect to natural length, we can say. Change of position with respect to natural length means whatever is the natural length of a spring, means in the relaxed condition. Whatever is the natural length of a spring, if we stretch it by X amount with respect to that, so the force developed will be proportional to that X. Minus sign indicates that if we stretch the spring rightward, the force developed will be leftward. And if we remove the proportionality sign, we can write it like F equal to Kx. So this is the relation for spring force and the extension or compression in the spring. Now what is this K? This K is called stiffness constant. Stiffness constant, also called spring constant. So this is the name of this quantity F. And what will be its unit? Unit of K. The unit of K will be what? This is force per unit length. So force per unit length means Newton per meter. So unit of K is Newton per meter. And K is property of a spring. K is property of a spring. This is property of spring. And how much is the K for different springs? If you see, suppose you compare two different springs. One is the spring for a refill of a pen, and another is spring for a shock absorber of a bike. So two springs if you consider. So the refill spring is very weak and the bike spring is very strong. So if you stretch both springs by 1 centimeter, the force developed in the bike spring, the bike shock absorber spring will be much larger. So K will be larger for the bike spring, and for the refill spring, if you apply some extension, suppose 1 centimeter, the force developed is comparatively small. If force developed is small, then we can say that K is small for the refill spring. So we can take example, the refill spring or ball pen spring, we can say the ball pen refill spring. Ball pen spring has less K, while bike's shock absorber spring has large K. So you can see that force here depends on the X and spring constant. So these are the two things which decides the force here.